This is lesson 312, Indirect Measurement, and got this little comic. The little red triangle is the female, the blue triangle is the red, and it says there are times when being almost right just isn't good enough. And she's saying, I'm sorry, Bob, but I'm still looking for Mr. Right. So sad. Bob's 91 degrees. He's just almost right. Alright guys, don't forget to give me your course and section number with all communication, and this can be found in the upper right corner of your geometry LMS. That information will allow me to help you faster. The objectives in this lesson are to use triangle similarity to measure distance indirectly, identify and use the proportional relationships between parts of triangles. The key term that this lesson is going to use is indirect measurement. And notice here it says it's a way of measuring a quantity that is difficult to measure by comparing it to a standard ruler or scale. There's a couple of theorems that we're going to use, and you need to know these theorems. Of course, you get to use your quiz, and you get to use your geometry textbook / reference guide for your quizzes and tests. So you need to know where they are in the index. There's a whole section of all the theorems and everything. But know where they are so you can access them quickly. But the two theorems are proportional altitudes theorem and the proportional angle bisectors. And it says that if two triangles are similar, then their corresponding altitudes have the same ratio as their corresponding sides. The angle bisector says theorem. Oh, that is the theorem. Whoa, that was the word. That's what I meant to say. If two triangles are similar, then their corresponding angle bisectors have the same ratio as their corresponding sides. That's very helpful information. This says direct measurement. Measuring directly. This means that if you were standing near a tree and wanted to know its height, you could measure it directly if you happen to have a tape measure long enough to allow you to measure from the tip of the tree to its base. And we're talking about a really, really tall tree. Okay, we're not talking about a little bitty brand new tree you just planted. Usually you can't measure them directly. Okay, that's just, it's not that it's impossible, it's just very hard to do. So we come up with indirect measurement. Now realize that when we're doing indirect measurement, we're still using similar triangles. So what we're doing is we're applying what we've already learned about similar triangles to real-world situations is exactly what we're doing. So indirect measurement uses the proportional altitudes theorem to find the height of any object with a shadow you can measure. And usually when we're doing indirect measurement, it's always going to involve right triangles, and the vertical leg is what we're going to be using as our proportional altitudes. So here's a vertical leg and here's a vertical leg, and notice they're both right triangles, and we're finding out, it looks like we're going to be finding out how tall this roller coaster is, so let's get to it. This problem says for a school project, Skyler needs to determine the height of the Texas Giant roller coaster at Six Flags Over Texas. She is 5 feet 3 inches tall and her shadow is 3 feet long. If the length of the shadow of the roller coaster is 40 feet, how tall is the roller coaster? So what you have to do is remember your similar triangles, and we don't have points named on them. Okay, so we're going to have to come up with a system of working this out. So what I want you to do, am I making sure I'm using the right color? I believe it's red, so you'll be able to see it. We're going to take, oh goodness, pen. I had the pen. Ink color is red. There we go. Hopefully it'll work now. We're going to take the coaster's height Okay, and we're going to put that over Skyler's height. We're going to take the coaster's shadow length. Well, I don't know what I was trying to write there, but it doesn't look like shadow. And we're going to put that over Skyler's. I just can't spell the word shadow today. Height. Okay. Now remember, in other problems I would go through and I'd put AB over CD equals DE over EF. I would always write out something like that. Well, since I don't have letters on these points, this is how I'm having to write this out. And I highly suggest that you do this. It just keeps you from making substitution mistakes. And y'all have seen me make substitution mistakes, but it was because I wrote out the problem, how I was going to set it up, is how I usually caught my mistakes. So the coaster's height, if you look in the picture, that's what we don't know. All right, and whenever we don't know something, we replace it with an X. And Miss Portia's having problems writing today. And then that's going to be over Skyler's height. Well, if you look here, it's 5 foot 3 inches. Well, 3 inches is a quarter of a foot. Okay, 3 times 4 equals 12. So 3 inches is a quarter of a foot. So it's going to be 5.25. And then I'm going to set that up to equal the length of the coaster shadow, which she probably measured right here and knew that length. And then I'm going to put that over the length of Skyler's shadow, which is that number right there. Then you're going to cross multiply. So I'm going to have 3x, and then 5.25 times 40 is going to give me 210. And then you divide both sides by 3, and you get x equals 70. So the roller coaster is 70 feet tall. Now, I don't know if the Texas giant is really that tall. Y'all probably know that information better than I would. I was just using it as an example. So that's how you do indirect measurement. So you could go outside, and if you got a flagpole in your front yard, at a certain time of the day you can measure its shadow, measure your shadow, know how tall you are, and you can tell how tall that flagpole is. Okay? It's a real world situation, indirect measurement. But you better do it quick so your shadow doesn't get longer or shorter. And there's the official answer. Alright, now this isn't necessarily a real world problem, but it's still the same situation to where we are using similar triangles, and we're using their altitudes to say why. Now this first one says, list the proportions that are true for each pair of similar triangles and explain why. Well, remember, when you're setting up a proportion, this is what proportions look like. AB equals CD. That's a proportion. So I'm going to use this proportion right here based on the altitudes. So remember, if you want, I'm coming over here to insert a segment. Hold on. The altitudes are the dashed lines. And so what you need to do is look and see what the letters are for that segment. Oh, there's shapes. I was kind of being brain dead there for a minute. I couldn't find. Oh, it didn't stay red like I wanted it to. Okay, that's about the best I can do that. I'm going to come over here. I'm going to change it to red and make it a little thicker so we can see it. There you go. So that right there is your altitude on the smaller triangle. And then we've got the altitude of the larger triangle. There we go. So those are our altitudes. So you're going to have, your problem is going to look like this. If I'm setting up a proportion, one way that I could do it is to say Km, that's my altitude, over QP. That's the altitude of the second triangle. Then you're just going to pick a side, and I'm picking this KL and QR. Oh, this board doesn't know how to spell a Q, huh? I was thinking Q and wrote a K. They sound almost alike, Q, K. I could see that. Let's say QR. So what we did was we took small triangle altitude. I'm gonna, well, I better not. Altitude over the large triangle altitude equals, well, I ran out of space, so I'm going to say equals small triangle corresponding side over large triangle corresponding side. Okay, that's how I set it up. But I didn't have to write it all out like that because I used the letters for the end of the segment. Another way that you could do this is sticking, you're always using the altitudes. Always use the altitudes, the height of the triangle. Notice how it's a right triangle. That's how you figure out the altitude. It goes from the vertex perpendicular to the base. That's always how you know what you're dealing with altitude. And you could use the side Kn over Qs, and that would be here. Those two sides. You could also write a proportion using this side. It doesn't matter, just as long as you have the altitude in there. Okay, there's the official answer. Using the proportional altitudes theorem, because it said to explain why. I didn't do that part, but it's a proportional